Let's observe the wood material applied to the sideboard drawer. The texture is not configured correctly. If in the camera view window we switch the working mode to edit mode and select the entire geometry, we can see in the UV editor window that there is no mapping at all. UV unwrapping is a process used in 3D modeling to transform a three-dimensional surface into a two-dimensional map. This allows textures to be applied precisely to 3D objects. Imagine you have a three-dimensional model, like a cube or a sphere, and you want to stick an image onto it. To do this correctly, you need to open up the model, laying it out flat so that every part of its surface corresponds to a specific area of the image. In practice, UV unwrapping allows you to define how texture images fit and are projected onto 3D surfaces, ensuring that details and proportions are correctly maintained on the model. So let's press the U key to bring up the UV mapping menu. Select the Smart UV Project option and then click on Unwrap. Let's go back to object mode and see how the texture now appears much more regular. As for the selectable options within the UV mapping menu, it's worth noting that in the context of our project we have relatively simple geometries, and the Smart UV Project option is a practical and efficient solution. This feature automates the UV unwrapping process, making it well suited for less complex objects without requiring manual seam placement. By using Smart UV Project, we can quickly generate UV maps that are well suited to our needs, ensuring good texture distribution with minimal effort. This approach not only simplifies the workflow, but also delivers effective results for uncomplicated geometries, making it an excellent compromise between speed and the quality of the final outcome. Let's move closer to the drawer and adjust the viewing angle so we can better examine the quality of the material. We notice an almost complete lack of reflection, and the material appears rather flat. The problem stems from an improper connection in Blender's node system. Specifically, we connected a glossiness texture node to the roughness channel of the Principled BSDF node. This causes a misinterpretation of the reflection information because the two channels handle complementary but opposite data. Glossiness indicates how shiny and reflective a surface is. High values correspond to smoother, more reflective surfaces. Roughness measures how rough a surface is and how much it scatters light. High values correspond to less reflective and more matte surfaces. To solve this problem, we have two options. Use a color ramp node to invert the values of the glossiness channel before connecting it to the roughness channel, or insert an invert color node in the connection. The color ramp node is useful when you need an inversion that isn't rigid, allowing you to customize each point of the gradient to achieve specific results. It offers more flexibility and versatility. It allows us to have greater control over how the values change and to add a smoother transition. The invert color node works by directly inverting the values and is the best choice when you need a quick inversion without any intermediate changes, and therefore no additional control is needed. It's a fast node and perfect for simple needs. Let's choose to use the color ramp node. Press Shift-A, type ramp in the search field and select the color ramp option. Place the node on the connection between the glossiness node and the principled node. Click on the downward arrow and select Flip Color Ramp. This will invert the values of the glossiness texture, turning shiny areas into rough ones and vice versa. After the inversion, the glossiness values will be correctly adapted for the roughness channel. A low glossiness value, which is not very shiny, will become a high roughness value, which is very rough, and a high glossiness value, which is very shiny, will become a low roughness value, which is not very rough. The color ramp node setup already seems to produce an excellent material. If we want to better control the reflections, we can easily adjust the two sliders, black to increase them and white to decrease them. This step is essential to ensure that the reflective properties of the material are accurately represented, allowing the Principled BSDF node to correctly interpret the texture information and create the desired reflection effect on the surface of the drawer. Another aspect we can notice by comparing our render with the reference image concerns the wood tones, which are different. Specifically, the drawers in the reference image appear to have lower saturation and a slightly more yellowish hue. Inside the shader editor, press Shift-A and type U to find the hue saturation value node. Select this option and insert the node directly between the output of the color channel and the base color input of the Principled BSDF node. Slightly lower the saturation to 0.85 and adjust the hue value just a bit. Set it to 0.51. Once the wood material is created, we need to apply it to all the other models that make up the body of the sideboard. So let's select the other three drawers, the top and bottom panels, the left and right side panels, and finally the back panel. Lastly, select the drawer to which we've already applied the material. Press Ctrl plus L and from the menu that appears, click on Link Materials. The same material will automatically be applied to all the models we've selected. As you might have guessed, now we need to texture each of them in order to adjust the texture on every geometry. Let's start with the second drawer. We select it. We switch the working mode to Edit mode. Select the entire geometry, press the U key, and from the menu that appears, choose the Smart UV Project option and click on Unwrap. Let's go back to object mode and repeat the same procedure for all the other models. The UV mapping requires further refinements. Some models, like the first two drawers, have textures that are too similar, while the side panels have textures that are incorrectly rotated. Additionally, the wood grain on the top and bottom panels appears excessively enlarged. So we need to work to make the textures as realistic as possible. Let's select the second drawer and switch the working mode to Edit mode. Select all the geometry and move to the UV editor window on the right. Here, select all the vertices. Press the GX keys and move them to the left, checking the result in the window where we set the material preview view. Select the top panel and set the working mode to Edit mode. Select all the geometry and do the same thing inside the UV editor. Move all the vertices toward the center of the grid and using the S key scale the geometry by a value of 1.7. Always check the result in the material preview window. If the wood texture still appears too large or too small, you can always adjust it through the UV editor window. Perform the same operation on both the bottom panel and the back panel. Now select the left side panel and set the working mode to Edit mode. Select all the geometry and in the UV editor window, select all the vertices. Press the R key and while holding down Ctrl, move the mouse until you reach a 90-degree rotation. Alternatively, you can press R90 to rotate the vertices more quickly. Looking closely at the panel, you can notice that the texture applied along the side of the thickness is not oriented correctly. So let's change the selection mode to Faces and select it. In the UV editor, only this part of the geometry is selected. Press R90 to rotate it by 90 degrees. In the material preview window, we can see the correct result. Now let's perform the same procedure for the right panel as well, where, to vary the placement of the texture, we can rotate it by -90 degrees. In this second part, we have therefore explored some detailed techniques to ensure that the final appearance of the material is as realistic as possible. In the third and final part of this lesson, we will proceed with creating the laminate material and the metal for the supporting structure of the sideboard, thus expanding our ability to work with different materials. Before finishing, as always, let's save the file incrementally.